When most of us hear the word probability, we kind of think of complicated math homework. But what if we thought about it differently? Not as a math lesson, but as a kind of master key. A key that can unlock the solution to all sorts of cool puzzles. So yeah, let's dive in.
Think about this. You flip a coin. What are the odds of getting two heads in a row? Seems simple, right? But it's a classic puzzle for a reason.
Or how about this one? What are the chances you pull a black king from a shuffled deck of cards? It's a totally different setup, a different kind of challenge.
And let's get even more real world. What's the probability that you and one of your friends have the exact same birthday?
See, each of these puzzles feels like it needs its own special approach, its own unique formula. But what if I told you there's just one tool, one single idea you need to solve all of them?
That's exactly what we're going to get into. We're talking about the master key to probability, a single formula that can handle all kinds of puzzles. And the idea behind this key is something called theoretical probability. Now, don't let the name scare you. It just means we're using logic, not running a million experiments. It all boils down to a simple comparison: the number of ways you can get what you want versus the total number of things that could possibly happen. And here it is. This is the master key. The probability of something happening is just the number of favorable outcomes, the stuff you're hoping for, divided by the total possible outcomes. That's it. So simple, but so powerful. Now, let's use it. And just so you know, any answer we get with this formula is going to fall somewhere on this scale. It's always a number between 0, meaning it's totally impossible, and 1, meaning it's a sure thing. Something like a 50-50 shot, like a single coin landing on heads, that's right there in the middle, at 0.5. All right, time to put this key to the test. Let's start with level 1, the classic coin and dice problems. This is where we really unlock the basics. Okay, here's our first challenge. You roll 2 dice. What are the chances you get a doublet? Like 2 1s or 2 5s, the same number on both? So to use our formula, we need 2 numbers. Let's figure out the bottom number first, the total possible outcomes. Just how many different combinations can you even get when you roll 2 dice? Well, here they all are. If you map it out, from a 1 and a 1 all the way to a 6 and a 6, you get 36 total possibilities. That's our bottom number. Now for the top number, what we're looking for. The doublets are highlighted right there along the diagonal. Count them up. That's 6 favorable outcomes. And now for the easy part. We just plug those numbers into our master key formula. 6 favorable outcomes divided by 36 total outcomes. Simplify that fraction, and you get a 1 in 6 chance. See, the key just works. Okay, good warm-up. Let's move on to level 2 and up the stakes a bit. Time for a deck of cards. So here's a puzzle with a little twist. We start with a normal 52-card deck, but then we take 3 cards out: the king, queen, and jack of clubs. Now, what's the probability of drawing a black king from that modified deck?
Okay, this is where we've got to be careful. Our total number of cards isn't 52 anymore, it's 49. So that's our bottom number. Now, what about our favorable outcomes? Well, a deck normally has 2 black kings, spades, and clubs. But remember, we removed the king of clubs. That means there's only 1 favorable outcome left in the deck, the king of spades.
And we just put it back into our master key formula. 1 favorable outcome over 49 total outcomes. The probability is 1 in 49. The same formula works perfectly, even when we start changing the rules of the game. So far, we've been dealing with dice and cards, but this master key isn't just for games, not at all. It's an amazing tool for making sense of real-world data. Let's see some probability in action. Okay, check out this table. It's from a medical study with 780 people. The question is this: if you pick one person from this study at random, what's the probability that they are 55 or younger and have had a heart attack? We don't have to guess, we just use the key. We look at the table to find our numbers. The total number of people in the study, our total outcomes, is 780. And the number of people who fit our specific description, our favorable outcomes, is 29. So the probability is simply 29 out of 780. All right, let's do a fun one. Vidhi and Anati are flipping a coin 3 times to see who drives. Vidhi wins if she gets 2 heads in a row. Anati wins if she gets a head immediately followed by a tail. So who's more likely to win? Well, with 3 coin flips, there are 8 possible outcomes, right? Everything from 3 heads to 3 tails. For Vidhi, 2 heads in a row happens in HHT,
HHH, and THH. That's 3 favorable outcomes for her, a 3 in 8 chance. For Unnati, she needs a head followed by a tail. Let's see, that's HHT, HTH, HTT. Wait, the slide says 4 out of 8. Where's the 4th one? Ah, I see it. It's THT. That HT in the middle counts? My bad. So that's 4 favorable outcomes for Unnati.
And there we go. With a 4 in 8 chance, which is literally 50-50, compared to Vidhi's 3 in 8 chance, Unnati is more likely to be driving. Our master key helps us settle the debate and find a clear winner.
So look how far we've come. We went from simple coin flips to card puzzles to real medical data and even settling a friendly argument. It just shows how this one simple idea can turn what seems confusing into something totally solvable. You have the master key now. It's just those 2 little parts. What you want divided by what's possible. It's more than just for puzzles. It's a way of thinking clearly about the world around you. So the only question left is, what puzzle are you going to solve next?